Hello, everybody, and welcome to the general chat track question and answer session. We hope you're enjoying your first virtual SciPy so far. I'm Gil Forsyth. I'm one of the program co-chairs. I'm joined by Matt Haberlin and Madikin Monk, who are also program co-chairs. And yes, we've got 7 speakers, hopefully, today. And so please, if you have questions, put them as each speaker is on stage, use the ask a question function, and we will read them and we will get you the answers that you deserve. That is our promise. And unless I'm forgetting something else, I think we can just get started.
Yep.
Which is great. All right. So we are going to start off with Sebastian Vettel. Sebastian, can you say hi in the chat, please?
I invited.
No, we're ahead of ourselves. That's great news.
Truly the highest quality Q&A.
Absolutely.
Hi.
Hello.
Hello. All right, so we have Sebastian Vettel here, whose talk was Align Incentives Across Use Cases for Domain-Specific Scientific Software. Thank you, Dylan. If you have questions for Sebastian, please put them into the Ask a Question thing. Oh, a question pops up. It's exciting. So Sebastian, you said in the talk that you would train economics students in software engineering as a research method. What would this replace in an economics curriculum?
That's a real tough question, and I don't really know myself. That's a tough one. But Chris Carroll, who's leading the EconArc project, I believe he's experimented with having it replace things like a mathematical methods class or be part of it. That's a tough one. Yeah, if it's too packed, maybe it's a specialization.
Gotcha.
Okay. I was also curious personally if you had any interaction with or planned to interact with the carpentries. So it sounded a lot. Your talk reminded me a bit about sort of where like mechanical engineering was a number of years ago, and kind of in a very similar sense of we all need to know how to code and no one seems to know what they're doing, and we have some kind of formalized education process to kind of tackle that problem.
That's a good call. This is really writing from our experience, Will and I, as research software engineers on the project. And I'm aware of software carpentry, but I don't think we've tried to sort of make the economics discipline gear up with software carpentry. Maybe we can talk to you at some point about how that works.
Yeah, absolutely. We've got another question here from Christine Smith. Software engineering is a complete degree, and then there's a lot you learn once you actually start working. What subset of software engineering would you actually put in economics?
That's a really good question. I guess what we go over in the talk is that there's certain things that are useful for doing the research, some things that are useful for publication, and some things that are useful for pedagogy. And maybe the software engineering skills could be divided up into multiple packages like that. I think for research, a lot of it's about making your code kind of legible and reusable, and sort of thinking in a way that sort of supports reuse, and certain kinds of sort of object-oriented programming and sort of sometimes functional programming paradigms are useful there. For the publication and pedagogy, there's kind of a split. Like a lot of it's about containerization and sort of building reproducible environments. And then another part would be how do you actually, it's sort of the chicken and egg problem. How do you set up the students to then contribute back to the code? Sort of like software engineering practice, like how do you like use Git or set up a development environment? But I agree, it's a vast field. I think part of what we're trying to argue for is just legitimize all that effort and skill set as something sort of more intrinsic to the research process as opposed to something extra added on, which I agree it's a big lift.
Great, thanks. Yeah, I mean, I can definitely get behind that too. I think it's a good thing to do.
Has that happened in your field?
I think it's in the process of happening. I think it's probably still right now in the base. I think certain programs, like certain universities and programs, handle it better than others. I sort of think, if I think about the way like Berkeley handles their sort of like general, like everyone should have some level of like data and computing literacy. I think that's been sort of a place where it's really kind of shining through. And others, in one of my former institutions, your computational training was a single semester of C, which I would argue is actually worse than no training, because all it does is scare you and leave you unprepared to do anything.
Right.
Yeah. Matt, you're muted. I don't know if you're...
I was going to say same thing here from engineering as well. Just one class in computer programming, and that's pretty much it. But it is tricky because, as the world develops, there's only new things to learn, and the old things don't really go away. And the things that are already in the degree, that are already filling up the degrees, are still important for the most part. So it's tough to find the space for them.
Yeah. So I've been following the Data 8 stuff at Berkeley. I was a student at Berkeley for some time in grad school. I do think we're trying to make a slightly different point about software engineering as opposed to computing and stats. So we go into this in the talk saying computational inferential thinking, it's great stuff. Constructionist learning through computational narratives, et cetera. It's a great paradigm of education, but the actual skill set of, like the social practice of me writing code that you would actually want to look at and build on top of is something that we're calling software engineering. And it's more of it gets learned often as like a professional skill. And it's hard to train formally. So actually in the talk and in the paper, we recommend a more kind of situated learning apprenticeship model about sort of like, what if there were courses where your coursework was to participate in an open source scientific community and, try to get your patches accepted. That would be a different thing than a classroom that teaches you about arrays. And so I think that's the kind of distinction that we're trying to make.
Absolutely. So Stanley B Burke in the chat, actually, and he's far too well-mannered to pose a comment as a fake question, but noted that an analogy here could be to writing as a professional skill versus writing as a profession. And I think that speaks actually just to what you were just saying, Sebastian, in the same way.
Hmm.
Okay, if we have any other questions for Sebastian, now is the time, and otherwise we will thank him for his time. Thanks, sir. And
Thank
I
Thanks,
believe
Sebastian.
next up then on our list is Stanley. Stanley, if you can say something else in the chat, we will then pull you up on stage.
I've got him.
You're on top of that clicking.
Welcome.
When I see Matthew's already trolling people with a past talk of mine.
He timed it perfectly for right as you appeared on the screen. It would have to defend it.
I was excited by the Twitter pushback I got on that diagram. That was good to see. So.
Well, now I'm going to go look at it while you're talking.
Well, so everyone, this is Stanley B Burke, whose talk was a continuous integration for scientific Python projects. And Matthew Feichert says it was great, and I agree. Stan, I don't know if you had an intro slide you wanted to share, or we can just hop into questions.
Yeah, not Not really. I think mainly it was just, the theme of the talk was basically, CI is intimidating, but actually beneficial for your productivity and also for onboarding new users. Just because it does. That was something that I didn't really appreciate until we started seeing contributors to Numba, in some sense, train themselves against our CI system. We would watch people make a series of commits, and as things got rejected, they'd be like, "Oh, okay, I need to go consider that on this platform." So that was something that isn't talked about a lot. A lot of times CI is seen as a focus on the core maintainers, but it helps even new people. So I don't know if other people have experienced that, but
definitely, absolutely. I found that adding like Black or any kind of auto formatter to your CI pipeline removes the need both for you to tell somebody, no, please just add a space here, but also for them to receive like 400 comments telling them, which, lines they need to fix, which is helpful. Yep. We do have a couple of questions coming in, so I will read them to you. All right. So from Michael Ackerman, is there a good resource where we can see examples of well-formed CI configurations and workflows?
Well-formed. First thing I would say is that unfortunately most CI configurations always look a little bit incomprehensible if you didn't make them. As I mentioned, CI is the result of failing a lot and then fixing it and then failing again and then fixing it. So it tends to not look super great. Although I do say the first thing I usually do is go to a trusted project, usually Pandas. I'll admit it here. I steal a lot of good ideas from Pandas, and go look at how they've configured stuff. I look at how they've maybe done Travis CI or Azure or that sort of thing. So I would say find a project that is had to do this before. Again, since these are all open source projects, it's easy to go look at their configurations, and that's usually where I start from.
Absolutely. I'll also, I wasn't directed at me, but I'll also plug DATS Gateway CI is bonkers. It's like spinning up Kubernetes clusters on Travis, and every bit of it is pluggable. If you're looking for a very complicated but well-written thing, if you need to do something truly complicated, that's a good place to start, I think.
Yeah. Jim, it was fun watching him build that.
I can imagine.
He looked very confused some days of I can't believe I'm doing this.
So the next question we have here is, can you tell us more about how Texas BBQ works? Can we use it? And yes. Suggestions for how we can run the code that actually changed first.
Yeah, so that's a good combination. Yes, you should take a look and use that. I mean, it's we wrote it for ourselves. Effectively, what it's trying to do is actually almost just making it kind of easy to declare for a project in a Python class how to check it out and run its tests. The main problem we had to solve with that is if you're doing that kind of downstream testing, you're running other people's test suites, not your test suite. The only difference is that you're putting your latest version in the environment rather than the last released one. So mainly it was just a way to encapsulate the recipe to run everyone else's test suites in a sort of flexible way. Because some projects we would check out master because they're very bleeding edge. Others we would take their latest release from PyPI or whatever. So yes, I would go take a look at that. As for the run first question, when I was writing that slide, I was sad there wasn't a really good recipe I could point to. The way we had to do this for Numba is for reasons. Numba has its own test runner. So the way that we implemented this, we had to kind of bake it into our own test runner, which isn't really reusable. A good generic way to do that, though, is just conceptually, is the system is basically looking at asking Git all of the files that have been changed in the, on this branch relative to the, where it forked off. And then any of those files that match in our test subfolder, we just basically pass that off and say, okay, go enumerate all the tests in that place and run them. So you could, with a little bit of shell hacking, you can probably get Git to give you that files and then pass them off to PyTest and just run things there. But that was huge. Once we did that, it was painful again to get set up. But once we did, our test suite takes 45 minutes to an hour, and being able to bail out after 5 minutes because the thing we just added is broken was a huge productivity win.
Do you think that could be generalized though?
Yeah, I think it could, and it may be something that we could. tangent, we've wanted to move Numba over to using PyTest as a test runner, and just haven't done the work yet. When we do, we will have to externalize that logic in a way that is reusable. So maybe we'll see that. Although I would also put it out there as if someone's looking for a sprint hack, putting up a recipe of how to run all the modified stuff first would be fantastic.
Who can we nerd snipe to make this a PyTest plugin?
Yes.
I bet that Medican and I can't do that this weekend.
Yeah, but it seems like a perfect sprint topic.
Yeah, it's nice, self-contained, and yeah.
Scott Collins recently moved to PyTest. I'm sure he would love to write a plugin as well.
Yes.
Okay, let's see what else we have on the question list here. What is the best practice for supplying input data files to the test suite?
That is an excellent question. If it is possible to have those checked in with your tests because they're small, that would obviously make sense. But I suspect this question is coming from you have test files that are not in the main source repository. In that case, in other scenarios, we've often would make a separate repository just for those tests. Like those are very heavyweight tests. I would move them out of your main unit test suite and put them in a separate repo with the data files if you can, and check those out as part of your CI system rather than checking out the main repositories. Various systems give you the ability to check out multiple repos as part of a test build. I'm less familiar with how to do that with Travis CI, but things like Jenkins, you can do that sort of thing pretty straightforwardly.
Okay, great. And it's time for one or two more. How do you stop the CI from confusing and demotivating contributors who aren't familiar with the workflow?
That's an interesting question. Oftentimes, actually, I think it's when you see the failure, sometimes what we have seen people do is to actually, again, they may be asynchronous from you, so there may be a time gap. But when you see that, it's the nice thing about the CI system is it may make it very obvious to you as a frequent contributor what the problem is. And so I think it's helpful to have people, even though a PR may be passing or maybe failing CI, to still have people looking at it and maybe helping out the contributor when they seem to be getting stuck on the CI. It's totally fine for someone to comment and say, "Oh, you're failing here. I think it's because of this," as opposed to waiting for the CI to pass to start code review. You can start it in the middle if it's needed.
Great, thank you. How are we for time? Let's see. Sneak in one more here. What are your thoughts on non-deterministic tests? Is it something to avoid if one can?
It is something to isolate if you can. I should say, for example, or at least to recognize when you have non-deterministic tests that's a pain you're going to have to suffer. In the case of Numba, we have a section in our test suite that is hammering on threading backends to confirm that having multiple backends doing things at the same time are going to pass. That is inherently non-deterministic. There is no way to make that deterministic. We just have to sort of you just have to kind of live with it. I think it's avoid the non-determinism if you can, but when you can't, it's just recognize that's where things will go wrong. It's better to have it and have it be a little bit non-deterministic than to just not test something.
Yeah. Okay. The last question here has got a couple of votes, and we'll go with votes. You recommended triggering the tests at a PR, but also trying to run the right tests for the code changes. Do you ever try to build a CI system clever enough to identify what the relevant tests are, or at least the test subsets, mostly for pre-PR active development?
So we've been fairly simple-minded in the past, just because that gave us pretty good bang for the buck, and just looking at test files that were touched. And that is, chances are, if it's a new code, you've added new tests. If it's updating code and you haven't touched any of the test files, then this doesn't work. And so we'll obviously have to just run the whole test suite as we normally would and won't be able to fail early. One thing we have also experimented with, and this depends on your code base, sometimes you can end up with especially when you have tests that check many permutations of different types and other things, you can run through the same code paths many times, and you need to do that for your tests, but you don't have to do it for a quick test. And so we have done experiments where we actually used coverage to try and build kind of a the minimum test suite that had 100% coverage, or not 100%, but had maximum coverage for our test suite, and save that off as here's a list of tests to run that take maybe 1/5 the time, but touch every file. That was an interesting experiment. We haven't really put that into production. So I would say I would resist the temptation to be too clever, because it could be a huge time sink, and is fundamentally hard to tell.
Okay, great. There are more questions, but I feel like we need to make sure we get everybody in here. So, Stan, thank you so much. It was great.
Thanks, everyone.
And let's see. Next up on the docket is John Kirkham. And while we're bringing him up, I will tell you that John's talk was on GPU packaging for the community. And he's here. Wait, yes, he's here. Great.
Woo, welcome, John.
How's everyone?
Great. Can you tell us it's like the best party?
Yes, I can. The chat is blowing up.
The chat is blowing right up.
So blown up. That's great. Continuously.
Okay, so if we have any questions for John, please put them in the ask a question thing down there. Matthias wants a one-stop shop for all packages. We all do.
We try to help.
Yeah. Well, we are waiting for questions to trickle in. I will ask one that is immensely self-serving, and with that caveat. So now that Conda Forge has GPU builds, is there an expected timeline for kind of Rapids and the associated suite of tools being available on Conda Forge, or are there any additional hurdles that are needed to kind of package something that big together?
We're working through getting CUDA toolkit packaged in Conda Forge, so it'll be like the libraries that you would include that are like acceptable by the EULA. Right now that comes from defaults, but that will be something that we're working on fixing. There are some dependencies of Rapids that are in Conda Forge, like we use CuPy heavily, for instance, and NumPy. So those things already exist. I think that's something we're thinking about long term, but don't have a timeline yet as far as Rapids goes.
Okay, great. Thank you.
Yep.
We've got a couple of questions coming in, so I will read them to you.
Okay.
Is there any effort going on to increase computational speed up for Python, as Julia is coming forward to give a tough competition to Python, especially for data science applications?
Well, we're trying to use GPUs. Admittedly, kind of a self-serving answer, but yeah, I mean, there are lots of people working on this for a long time in Python, right? SciPy, Conda Forge, for instance, is building out a lot of PyPy packages. I don't know if that's widely known. But we have a decent amount of the stack covered there, and a migration that's trying to cover ideally the entire stack. Like you can install Jupyter Notebook today and get running with that.
Great. Michael has noted in the chat that other Q&A sessions have had each speaker give a quick summary of their talk. John, if I can put you on the spot, or I can just keep asking you questions, but if you want to give just a quick overview of what your talk was about, just to remind folks.
Sure.
That seems like a fine thing.
Yeah, I can do that. So basically, we were showing how packaging in the Python ecosystem has evolved, sort of from a language that was just fun and easy for people to write in to trying to attach performant, well-optimized academic libraries like Netlib and things like that, and how this has continued today to include GPU libraries, et cetera. And then finally showing how we've done this for Conda Forge and worked with the community to add some GPU packages along these lines, and kind of provide that framework, that scaffolding for others to build other things that they might be interested in. Does that cover it, I think, or are there other?
I think so. And thank you for doing that without on the spot there. Let's see, got a few questions here. Are consumer NVIDIA GPUs effective for scientific computing? There's a line here about possibly consumer GPUs limiting their floating point calculations.
So you mean like in a laptop that you might have? I'm maybe not the best person to answer that question. I would ask Keith Krause, actually. He has immense details about different types of GPUs and which are performant for different things. Yeah.
Okay. Well, we will direct that after to Keith. I'll give him his Twitter handle.
Everybody can go right now and ask that on Twitter.
Yeah.
He's also very responsive on Slack, and so.
Ooh, pro tips happening here. I like that.
Stan has also pointed out in the chat that consumer GPUs are great for single precision work. Are there any plans, and John, you don't have to answer this if it's going to compromise your employment, any plans to release packages for use with AMD GPUs?
No comment.
Okay, noted. That is just fine.
Silence.
And we have a very important question here from Matthias, which is, what is the capital of Assyria?
I actually don't know.
Neither do I. So we're probably both in trouble then.
I think that was a Monty Python Holy Grail reference.
Yep, totally missed it.
The follow-up was,
no. Let's just talk about swallows instead.
Swallows are safer.
you could also answer as an alternative, what is your name and what is your quest?
I think that's what we can ask all our future speakers.
I think that that's a good move.
Mm-hmm.
Okay, so I think we've exhausted the questions from the audience for now. So if no one else has anything further, we can bid John a fond farewell. Okay, well now the chat's just gone into the capitals of Assyria. That's where we're at now.
Yep,
I did that. That was my fault. Mostly Matthias, but also mine. Okay. Well, thank you very much, John. Good to see you. And everyone check out his talk on YouTube if you haven't seen it yet.
Thank you.
And the other ones too. I should have said that for everyone. Okay. Next up, we have Aaron Gott. And while we are waiting for Aaron to make his way to the stage, his talk is, I look at my list, Jupyter Notebooks for Spacecraft and Robot Dynamic Simulation.
Hello.
Hey, Aaron.
Can we give a 2-minute kind of background of your talk before we get into the Q&A?
Yeah, let me just share my screen here.
I can.
There, can you guys see that?
Yep.
Okay. Yeah, so just to give some background on my talk. So I'm a member of the Jet Propulsion Laboratory, and I work on an in-house simulation framework that does like physics simulations, and it's used across a wide variety of missions. And we have a pretty large code base, and we've recently started to get a lot of new users. And so as a result of that, we kind of turned to Jupyter Notebooks as a way to make running our code, which is fairly involved to set up, more accessible to new users. And so the talk was kind of a tour of how various ways that we've used Jupyter Notebooks over the last few years, and some of the internal development we've had to do to kind of enhance them for the things we need. So for example, adding custom notebook extensions for like 3D graphics, things like that. And also, so it also covered a bit about some of the things we've done with notebooks. So for example, we had a week-long course that was partially just PowerPoints and slides, but we also had a lot of interactive sessions using Jupyter Notebooks where the attendees could actually run the simulations. And because we were providing like a Jupyter Hub server, nobody had to have the software actually installed on their computers. They could all just execute it remotely. So it was actually a huge boon to us to be able to do that. And it really simplified the logistics. And so, yeah, the talk was really just kind of a look into this particular use case for Jupyter notebooks. So yeah, that's pretty much it.
Okay, great. Thank you for that background. I know we kind of sprung that on you a little bit.
That's all right.
We have a couple of questions, and people can keep asking them. I'll read them out loud, and then you can answer them as we go. Our first one is your simulation software or Jupyter Notebook extensions, are they available? And if so, where are they available?
Right. So the simulation software is not open source, unfortunately. For one thing, there are kind of export control issues there. It could be used to, build a simulation of a ICBM or something. And so there are some issues with releasing that to the public. Currently, the notebook extensions are also not open source, but that's something that I want to push on. There's some internal process that it has to go through to open source it. But it's definitely on the horizon, is something we would want to do. So there's 2 notebook extensions in particular. There's one that basically right now it can hook up to the simulation to do 3D visualization of what's going on in the simulation using WebGL through the 3.js library.
Excellent. That's super cool.
Yeah, that one is pretty popular internally. And then we also have one that uses the Viz Network JavaScript library to do graph visualization. And that one's also pretty handy in the context of simulations for showing the topology of different aspects of the simulation.
That's really, yeah.
Those are 2 that we definitely like to open source. Yeah, ITAR, exactly. The International Treaty of Arms Regulations or something like that. Yeah.
Yeah. As a nuclear engineer, I'm also very, export control is something I love dealing with. That's great.
Yeah.
So, I feel your pain quite a lot. Yeah. Okay. Our next question is, did placing darts behind a Jupyter hub alleviate export control concerns?
No, not really, because the people using the notebooks can still access the source code. It's possible to go into a terminal within the notebook interface, and you can pretty much access a shell and get to stuff on the file system that way. So everyone still had to be cleared through export control to actually access. So everybody attending the course was cleared ahead of time.
And then that was an internal instance.
Yeah.
Okay. Okay, so our next question is, are you able to make your Jupyter Hub servers available outside of JPL? How did you handle authentication? I think this maybe you kind of touched on a little bit. So
so there's 2 ways we handle authentication. For people internal to JPL, they're able to use our internal authentication with LDAP. And then for external users that we've cleared, we just use a hashed and salted password. So they're able to log in with username and password. Okay.
Are you guys using ROS or did you see the Jupyter ROS extension?
I'm actually not familiar with that extension. We do use ROS just with our, from the command line, which is 90% of the time that's what we use our simulation code. But that's actually interesting, and I'll definitely Google that after this.
More extension. You're extending.
Yeah.
Yes, excellent. Okay, next one is, could you suggest a good library for mobile robot localization, especially based on Kalman filter / computer vision based approaches?
I'm not sure about that one. I'm not really an expert in that area, so I don't really have any advice there. Whatever we use is probably an internal tool, so I'm not sure what I could suggest there.
Yeah, that's totally okay. We're here to really stump you with questions. So that's the goal. So great job. Last one is how much work.
Somebody in chat mentioned filter pi. Maybe look into that.
Okay, there we go. Yes, thank you. See, you're answering. You can use other people's answers as your own answers.
Exactly.
That's really the goal. I mean, that's how I set up my CI. So anyway, okay. So last question is, how much work is running your own Jupyter Hub server?
The initial setup took a while to get everything figured out. But once we've got it set up, I mean, there's very little maintenance that goes into keeping it running. So yeah, I would say initially it took a few weeks to get everything figured out. We had to do some custom development. We used a custom authentication extension that did all of the LDAP business. And we also developed a custom spawner, which is the component that actually goes and spawns a single user notebook server once authentication has occurred. And so we had to develop those two extensions and figure out some network issues. And all of that took a few weeks. But once we've got that set up, there's been very little maintenance burden on the actual server. Yeah.
Excellent. Okay, so we have so we have another very serious question from Matthias. Is this a 5-minute argument or the full half hour?
I'm sorry?
I think this is making another Monty Python reference. So maybe Gil has something to add.
Which movie is that from? I'm not actually. I feel like I know Monty Holy Grail by heart.
I think that's a Flying Circus reference.
Never seen that one.
Yeah. Matthias, we're really failing you. I'm very sorry. Okay, last one, I think. Do you know if there's a good way of turning Jupyter notebooks into standalone Python scripts with minimum cleaning, such as removing output cells?
What I've done in the past is I just use the NB convert utility, which is like the pretty standard way of doing it. If you don't want there to be output cells, it might be easier to just delete the output cells in the notebook interface first. You can just clear the output in the notebook interface before you run NB convert. That would be my approach to it without doing more research on it.
Okay. Yeah. Okay. So I think this is related kind of to your last one a little bit. Do you, since you have this like whole internal instance of your Jupyter Hub environment, do you have issues upgrading it specifically with respect to the software available to the users? And what is your process like to do that?
So we have we use a containerized instance, and so we maintain our simulation software on our local file system, and we can update that as we need to using our own version control system, and we mount that into the container when we spawn a server instance for a user. So updating that is fairly simple. And then as far as updating the Jupyter Hub version itself, that's been fairly painless in the past. It's just a matter of running the command to update it, pretty much.
Okay, well, thank you for answering all these questions. Yeah.
One more thing about that is one issue we are going to run into pretty soon is Jupyter Lab. So from what I understand, the notebook extension interface has changed pretty significantly with Jupyter Lab. So we are able to just run our Jupyter Hub server with Jupyter Lab, no problem. But currently the extensions don't work because of those changes in the interface. And I last evaluated this maybe a year ago, and at that point it seemed like the interface was fairly unstable still, but it may have stabilized a bit more since then. So we would like.
Maybe this could be another sprint project. See, we're just going to keep suggesting stuff now for everybody. Yeah. Okay. Well, thank you, Aaron, for answering all these questions. We really appreciate it. Thank you, everybody, for asking great questions. And sorry again, Matthias, that we're not handling your Monty Python references as well as we should. So next up, we have Matthew Fikert, and his talk is PyHF, or maybe we have a different pronunciation. You can correct me when you get up here. A pure Python statistical fitting library with tensors and AutoGrad. And I think once you get up here, you can also explain and help Gil and I really understand tensors from a physicist perspective. Because
hello.
Hello.
Also, do you mind if I share my screen? So yes. Can I root one of you? Sorry.
I'll pop out and never mind. Gil's going to pop out.
Okay. Cool. Okay. So I should be sharing now. Yes.
Yep. Yep.
Yeah. Okay. Cool. Yeah. So, hi everyone. Thanks very much for having me. And then I'm also presenting on behalf of my other co-authors, Lucas and Jordan. Right. So I guess like a quick summary of what PyHF is and what my talk was about. So PyHF is a pure Python statistical fitting library, and this comes from the experimental high energy physics community. So the main goals here of what PyHF is we want to try and provide accelerated fitting so we can help reduce the time to inference and insight for experimental high energy physics. And one of the ways that we actually go about doing this is by taking advantage of all the really nice libraries that are out there right now that provide n-dimensional array or tensor libraries along with computational graphs and auto differentiation. So that allows us to take advantage of both the vectorization and hardware acceleration on GPUs, in addition to the fact that with automatic differentiation, we get access to the full gradient of the likelihood, which when we hook that up with modern optimizers, really speeds up the process. And then we've gone ahead and just made this kind of, we've produced kind of a backend agnostic shim layer. So that allows us to support backends that are implemented in both NumPy and SciPy, as well as TensorFlow and TensorFlow probability, PyTorch, and JAX. And then along the way, we've also produced we've moved from using the previous field kind of standard of this domain-specific binary file format for actually storing the likelihood. We have now developed a declarative JSON spec for the whole likelihood, which has made reinterpretation and preservation significantly easier. And along with that, we've been able to use the fact that JSON patch exists really nicely to help separate our background-only model from our signal model when we're looking for new physics. So we can kind of store the background model independently from the signal model, so that way if in theory or experiment, if we come up with a new physics model that we want to test for an already existing background model, we just can go ahead and use JSON patch to just patch in the new signal model and test. So that's a really nice advantage of the JSON spec as well. Right, so that's probably hopefully a good 2-minute summary or so.
Yeah, that was a fantastic summary. Thank you. Also, very good resummary of your talk.
Well, thanks.
I'm going to ask some questions in the Q&A, and then if you do minimize, if you want to leave your screen up, we can do that. Otherwise, sure, we can have Gil rejoin if you don't want to have it up.
I'll go, no offense, Gil, but I might go ahead and leave it up just so I can tab through slides.
No, yeah, totally. Do not worry. It's totally fine. Okay, so our first question is, how are gradients computed when using NumPy numerically? Were you able to compare the performance of any backends with and without AD to see how much that speeds things up?
Yeah, so at the moment, maybe this isn't the perfect slide for that, but at the moment, I don't actually have a slide dedicated just to the optimizers, but at the moment we don't, obviously, because for SciPy, since there's not full gradients there, we have to still go ahead and compute things numerically, but sometimes when we're using the SciPy optimizer, we might also we just use SciPy optimize, but we also have an additional kind of more domain-specific optimizer that will sometimes switch out there anyway. But we haven't really done a formal study of how much auto differentiation really accelerates things, but I can tell you just from our personal experience with using PyTorch and JAX that it's significant. We definitely see that when we move to using PyTorch or JAX, we can see like huge increases. So we're trying to actually formally understand that a lot better, but that's something that since PyHF is still under active development, we're kind of trying to do in stages.
This is just a personal question for me. How many developers do you have working on this?
So it's just 3 of us. So it's going all the way to the start of my talk. It's just myself, Lucas Heinrich, and Jordan Stark. And so the 3 of us were all postdocs on the Atlas experiment, and we're located at different places around the world. Lucas is a postdoctoral fellow at CERN. I'm at University of Illinois, and then Jordan's at UC Santa Cruz.
Okay, excellent. Thank you. As a postdoc also, we get lots of cool development work, right? So, it's fun, but also then you have to find people to continue the work if you move on. So
yeah, exactly. Well, that's kind of one of the reasons that I think it's maybe important that I mentioned that I'm partially supported by IRISEP, which is a software institute. So I'm 50% a postdoc on the Atlas experiment, 50% a research fellow, IRISEP, which is the Institute for Research and Innovation in Software for High Energy Physics. And so this work is partially supported by the Institute. And then as this is part of like a continuing effort in the Institute to reduce the time to insight and provide end user analysis tools, this is where we hopefully can, even if I leave for industry or something, eventually we can have this tool live on.
Yeah.
With good support.
So you have like a long-term sustainability sort of plan.
That's so we're very, very, very luckily, one of the members of IRISEP is Dan Katz, who's at Illinois and at NCSA. And so since Dan is both a member of JOS and then also, or an editor at JOS, and also a true expert in the term of long-term sustainability of software tools, we have frequent discussions with him on these things. So we definitely are very lucky to be able to have conversations with him.
Excellent. Okay, so we have another question. Did you say you're using a generic SciPy optimizer for MLE rather than something specialized for your problem? And if so, which one?
Yeah, so we are using like the SciPy optimized, but we've done a little bit of tweaking. So we're not just doing like Newton's method or something like that. We've tweaked it a bit to our we've gone ahead. We are using out of the box SciPy optimizer algorithms, but we do a little bit of additional tweaking as well. And as I mentioned, we have our SciPy optimizer, but then we additionally go ahead and for some of our cross checks, we have some people may be familiar with the MinUE algorithm for minimization, and we have an implementation of that as well that we use to check. And MinUE is very specialized for high energy physics sorts of problems.
Okay. So another one is, have you talked with people about other domains where your library might apply? And if so, can you say a little bit about that?
Yeah, thanks for the excellent question. So it is definitely the His factory statistical model, which is what PyHF focuses on implementing. Where, to be very clear, we are not kind of a solution to the open world of statistical models. We're really just focusing on taking this one ubiquitously used statistical model and trying to maximize that as much as possible. But at the same time, as long as you can basically formulate as long as you have a counting experiment and you can basically formulate your question in some way that you actually have bin data, then you can shoehorn it into the model if it makes sense, of course, right? We don't want to be applying statistical models in crazy ways. So here, this is kind of a example that my colleague Lucas Heinrich has looked at in using data from the Fermi-Lat telescope to analyze it using PyHF, and then to also do some visualization of the full sky here with this best fit model. So this is something that's very kind of exploratory. We haven't really made a real effort to kind of connect with people in the astrophysics community, but this is on the radar. And we're also currently having some discussions with people who are doing dark matter research as well.
Excellent. That's very cool. But I'm just going to say I like to apply random statistical models just because. True chaos. Okay, so Gil asks, apples to apples comparisons are hard, but when comparing performance gains against Root, the C++ alternative, was the NumPy backend competitive?
Yes. And yeah, so one of the reasons is because we can still form a different computation, even though we can't take full advantage of auto differentiation with NumPy and SciPy, we still do gain from the fact that we fundamentally structure the computational graph differently. And with all of our tensor backends, we're able to basically structure it so we can trade all of the kind of, on this slide, on slide 21, all of the just computational complexity. We can then merge all of our different subparts of our models to try and combine combinations. And then just through the vectorization that we get anyway with all of these libraries, that still provides a huge win. So like this slide that's showing right here is the computational graph that was used in the 2012 discovery of the Higgs boson in our C++ framework. And on slide 20, that it's pretty maybe small and so pretty hard to see, but this basically is like the full HIST factory statistical model graph in our implementation. And just the fact that you can actually see where the models come in, where the model parameters come in versus where the data comes in, and the fact that these graphs are kind of factorized already just using the NumPy and SciPy ends is in most cases significantly outperforming the C++.
This is extremely cool. Thank you so much for answering all the questions. And thank you for coming up. We really appreciate it.
Yeah, thanks.
Yeah. So next up we have Wolf Wolfprecht, scikit geometry and generic computing in Python. So I think Gil is also going to come back up, and maybe Matt, or I can just be here alone, you know.
Hello.
Hello. Welcome, Wolf.
Nice to see you.
Nice to see you as well. Do you want to give a quick introduction or like recap of your talk, the condensed soup version, condensed geometry?
Sure.
That would be like a line.
Yeah, so scikit geometry is a library that we've developed at QuantStack. And my background is in robotics, and in robotics we often have to do with stuff that needs some geometric algorithms. And so scikit geometry comes with a bunch of entities that can be used to do geometric computations. So the basic thing is a point, and then from a point you can form a line or array or vectors and this line segments and so on and so on. And then you can use the library to do intersections, and you can also have polygons, and you can grow and shrink polygons or intersect them, create the difference or addition and so on. So many operations are available already. And the library is based on Seagull, which is a C++ library that is basically the standard for geometric processing. And in my talk, I was also quickly going over a different library that we are also developing, which is called Adjacent. And that is a geometric constraint solver, which can be used to basically say that two lines are supposed to be parallel or rectangular to each other or meet in a certain point and so on. And the third thing that I was briefly talking about is generic programming and how we could make Python look a little bit more like C++. That's it.
Thank you, Wolf, for that. Yeah, I think Joe Jevnik also has a good talk on trying to make Python use C++-like syntax, but it was horrifying when I saw it. But hey, you know.
Yeah, we have a bit of a C++ background at QuantStack, so there's a temptation.
You should talk to Matthew Fikert about the performance in his statistical fitting models. We do have a question from the audience, which is, can you give examples of problems that don't initially appear to be computational geometry problems, but can be solved with computational geometry?
Oh, wow. And a problem that doesn't appear to be a computational geometry problem, but can be solved with computational geometry.
Maybe a problem that doesn't, if there are any problems that sort of fall outside of the realm of, like a geometric constraint solver is sort of like, it's a CAD problem. You can, like, that's sort of obviously geometric. Is there anything that kind of falls outside of the, outside of that realm, I guess? And if not, that's okay too.
That's a very tough question. Yeah, I don't think I have a good answer right now.
there may not be a good answer to it, so that's okay.
In robotics, most problems we try to solve are pretty obviously geometric problems. So usually what you have is like things like visibility computations. If you have a robot that is somewhere and you want to figure out what is the shortest path to go to a certain goal or something like this, and then you try to find intersections with the environment and so on, or figure out like what can the robot see with its laser scanner and this kind of stuff. But I guess this is not really a problem that would not obviously be a problem that can be solved with computational geometry.
That's okay. I had a question about scikit geometry and sort of its. So you mentioned in your talk that so you're replacing some less than Pythonic Python bindings in Seagull, and is there anything that is exposed in the Seagull bindings that isn't sort of yet represented in scikit geometry, or is it sort of at this point? I mean, it's not a replacement because you still need to have Seagull in the background, but is it at this point can it kind of cover most of the functionality that's available there?
I think it does cover most of the functionality that is in the Swig bindings from Seagull, but I would need to check what the exact overlap is right now. But yeah, I think PyBind 11, the library that we are using, is like really a wonderful library that is super easy to use. If you know a little bit of C++, it's very straightforward to create the glue between Python and C++, and it's beautiful code and it works really, really well. And it really helped us to basically create bindings that also expose iterator methods and stuff like this, so that you can just use them in Python as if they would be natural Python objects.
It's very cool. Could we use PyBind 11 to create Python bindings to Xtensor?
You can actually, and that's in the Xtensor Python project. So all of the work has basically already been done, and you can, I mean, for people who are not familiar with Xtensor, it's another C++ project at OneStack where we try to re-implement NumPy in C++. And one of the goals for Xtensor is to make it interoperable between different languages, or basically you write your math problems once in C++, then you can create bindings from Python, C++, R, and Julia and use them in the same way.
Great. Thank you for giving a very good answer to my kind of silly question. We do have another question from the audience here. What are plans to add other objects, e.g. a torus?
Yeah. So that's, I'm not sure if a torus is actually part of the geometric kernel in Seagull. There are certain objects, and so basically you have a geometric kernel in Seagull, which has things like the point, line, segment, and so on, and then defines operations on those. But it's not really complete in the sense that, for example, if you have the regular kernel, you don't really have an arc or an ellipse and stuff like this. And I would really like to see this kind of bit more fancy objects added to scikit geometry. So we'll have to figure out if we extend the Seagull geometric kernels to also include those kind of objects, or if we find another way to maybe create a new kernel that maybe is written in Python and then accelerated using JIT algorithms, which will also have nice benefits in the sense that you could integrate it much deeper into the Python ecosystem and do things like automatic differentiation and stuff like this on those kind of problems.
Okay, great.
Yeah.
All right. Do we have any other questions from the audience? All right, great. Wolf, I think we can let you go. Thank you so much.
Thanks a lot.
Thanks for coming up.
Yeah, see you.
Okay. Okay, and I think our last speaker for the session, we have Melissa Mendonça, and her talk is on F2Pi. Melissa, are you here? Is she coming up? Hey. Hello. Okay. Can you just give us sort of a short summary of your talk, and then we will start fielding questions from the group.
Yeah, I think I have a bit of a lag towards you, but that's okay. So I don't have any slides or anything, so I'll just talk a bit about the talk. It was mostly updating the current work being done on F2Pi. So for those of you who are not familiar with F2Pi, this is a submodule of NumPy that does interoperability between Fortran and Python. So the idea is that if you have Fortran code that you want to rep and then use it as a part of another Python code, you can do this using F2Pi. And you can also do callbacks. So this means that you can use F2Pi to wrap your Fortran code, and then you can call Python objects from inside Fortran. So this also works for C. So F2Pi can also wrap C code and generate C extension modules that can later be imported in Python. So some of the functionality of F2Pi is used in a bunch of other packages in the scientific stack. For example, SciPy uses F2Pi extensively. And there are other big projects that are relying on Fortran for fast code, especially projects that use atmospheric data, climate data, and geophysics, physics, and other projects that have to handle like big amounts of code and have to do computations fast. So yeah, there's still many projects using F2Pi. However, F2Pi has been for a few years a bit on just barely maintenance mode. So there was no official maintainer. And so we are trying to change that. We are trying to pick up on F2Pi and continue the work, maybe extend some of the functionality, because F2Pi has been so it supports Fortran 77 and 90 partially, but hasn't been updated, and Fortran has been updated. So we have Fortran 2018. It's the latest standard for the language. And so we would like to modernize F2Pi and bring it up to speed with Fortran. I guess that summarizes it.
Fantastic. Great. So I think we have at least one question here, which is why is the Fortran converted into a C extension for Python? Does Python have special native support C extensions? And does that mean that there's some overhead in that you might have Python calling C code, which then calls Fortran?
Yeah. So CPython is built on C, right? So the C extensions are easier to deal with. So what happens is that you create the C extension translating the data model from Fortran to C so that you can understand that inside Python. And also because so much of NumPy is connected to the C level implementation, that's easier than just bypassing it all. So there are some other projects that have other approaches. For example, there's been a lot of work on building LLVM-based compilers for Fortran. And so that might allow different kinds of interoperability between Fortran and other languages. But yeah, for Python, it's because of the CPython implementation and the C extensions that are already available in Python.
Great, thank you. I also had a question. No. Okay, so I had a question about, I was wondering if there are any tips, potential pitfalls around, so like C uses row-based memory groups and Fortran uses column-based memory groups, or it used to. And so is there anything to sort of be aware of or anything to be cautious about when you're kind of swapping back and forth between them?
Yeah, you have to be mindful of that explicitly. There's no other way. Like, you have to tell your program which order you're reading your arrays. There's no much there's no way around it. So NumPy has some functionality around that. So you can create NumPy arrays using Fortran or C order. And so if you're reading stuff from Fortran and then building it to NumPy directly, you don't have to do anything. F2Py will take care of that. So that's not a problem, unless you're doing something different, or creating the data pointers yourself. You don't need to worry about that in principle. But yeah, I think most of the pitfalls that I see people having trouble with have to do with the header file. So in order for F2Py to understand your Fortran code and correctly translate it into the C extension, sometimes you have to write a small header file, which contains the interface to your Fortran subroutines and functions and modules and or data. And so this header file has to be correctly formatted and has to have the right options so that F2Py can correctly translate all that information to Python. So there's definitely one of the things that we're looking at is improving the documentation for F2Py so that people can better understand how to build the header files.
Okay, very cool. Thank you. We have a question relating to LLVM Fortran, which is that are there any plans to explore, or has anybody tried to use LLVM Fortran with F2Py?
Not yet, but this is something. So Andrzej Chertik is working on this for L Fortran, and we have talked about maybe doing some integration of F2Py, but that's not started yet. So it is possible, but I don't know.
Hey, open questions are great. That's more work for people to jump on. Actually, I will say there's been a bunch of comments in the chat, and they're all people expressing a lot of love for Fortran. So if you have a bunch of Fortran lovers in the audience, is there a good way for them to get involved with F2Py? How can we reach these Fortran lovers who have clearly been waiting to express this?
So F2Py is part of NumPy. You can just come to the NumPy GitHub, open issues, and especially I think I might. So I hate recording talks, so I was not happy with my recording. But one thing that I failed to mention was that it would be really, really nice to have feedback from people using projects that depend on F2Py, so that we have issues and feedback and features you would like to see added so that we have a better sense of where to go from here. And also check out, I know this is a Python conference, but you can check out fortran-lang.org, which is a website for the Fortran community. So if you want to check it out, this is something that's being built. So it's not established yet as a community, but some very good people are working on it. So if you want to join, would be nice to have more people.
And if we've had a Julia tutorial at SciPy, I'm pretty sure we're allowed to pitch Fortran Lang. That's just fine.
So, in Python Brazil, we always have a keynote who talks about another language other than Python. I think that's healthy for the community.
I completely agree. Absolutely. All right. Well, I think that is what we have for the questions here. So, Melissa, thank you so much for coming by. We really appreciate it. People in the chat there, you can see there's a couple of links for Fortran stuff, and please get involved if you're interested.
Thank you so much.
I also think we've got just a few minutes left, and there was, I think, a question that came up for Wolf right as he was leaving that we can try to bring him back for if he's around. He is on the way.
Hi.
Welcome back. Thank you for agreeing to drop back in really quick.
That's a difficult question again.
Yeah. So there was a question that came in right as you were leaving, which was there's a package called Shapely that handles computational geometry for GIS data. And can you elaborate on the differences between scikit geometry and Shapely?
Yeah, so Shapely, as far as I'm aware, uses the GEOS library as a backend, basically, for the computations. and it's more geared towards GIS applications, I think, where Seagull is really geared towards like computational geometry and maximum precision. And I think psychogeometry comes with more entities, kind of. So you have things that basically stretch into infinity, like a line, as well as a ray. And you can express what a circle is in psychogeometry, which you, as far as I'm aware, cannot really do easily with Shapely. And so that's kind of the main difference, is that in Shapely you are a bit more limited, and it has fewer functions also when you go to higher level functions like Voronoi diagrams and things like this. So that would be my answer.
Great, thank you. And then there was one other question, which was how should someone get started with scikit-geometry if they're interested?
Yeah, so we have a binder now. So you can go to the scikit-geometry GitHub and start or launch a binder from there, and that will give you an interactive notebook where you can run a bunch of examples and get used to scikit-geometry, and then you can install it using your favorite package manager, which is Conda or Mamba, if you're a little bit experimental.
Okay, fantastic. Thank you so much for jumping back on for those questions.
Sure.
That is the end of our time, everybody. So thank you, everyone, for coming. And thank you to all of our presenters for answering questions. And please stay tuned for the lightning talks coming up at 5 p.m. today for the last round. And thank you, everyone, again for coming.